Hey guys, how's it going? Today I'm going to review the Johns Hopkins University Data Science Specialization on Coursera. So what it says here, launch your career in data science, a 10-course introduction to data science developed and taught by leading professors. So it has 4.5 stars on 38,000 ratings. That is a sufficient amount of ratings and a good enough rating to say it is very strong, rated by the people. So who is teaching this thing? Well, Jeff Leake, PhD, and two more. He is a biostatistics professor, and so is Roger, and so is Brian, and they're the three professors, or the three instructors. They all are PhD in biostatistics. Why is that? Because Johns Hopkins is a very medical-based university, as many of you may know, and so it's kind of unsurprisingly, it has a bio theme there. So in the About section, we can see just under the ratings, we have what you will learn. Use R to clean, analyze, and visualize data. This course is in R. Some courses do a little bit of Python, a little bit of an R, Excel and other things. This is a course in R for sure. Use GitHub to manage data science projects. So of course, to actually make that R code usable, you're going to use GitHub all the time. Navigate the entire data science pipeline from data acquisition to publication. Publication is kind of an interesting term. You might publish a research paper, you might make an application, you might deploy it somewhere, who knows. Perform regression analysis, least squares, and inference using regression models. That I don't think is overly surprising. Regression is definitely a key data science topic for sure. So skills you will gain here show all: GitHub, machine learning, R programming, regression, data science, RStudio. Of course, you're using R, pretty much always use it in RStudio. Data analysis, debugging. It's actually interesting. Most of them don't do debugging. Data manipulation, regular expressions. I'm very happy that that comes up. Data cleansing and cluster analysis. Okay, cluster analysis is also interesting because not all data science courses do clustering. So I'm going to skip over this section here. Of course, there is a shareable certificate that you may want to consider. Beginner level, so you should have beginner level experience in Python. That's funny. It says you should have experience in Python, and it's a course in R. It's because they kind of want you to have programming experience. If you're doing something in analytics, they're guessing that you've already done something in Python, so that's what they write. But don't be confused. This is not building on Python skills. They want you to have a little bit of programming familiarity. A little bit of regression is recommended. I think it's probably okay, though, if you jump into it. Maybe if you have trouble, then you can go back and do regression. Okay, so looking at the courses, there are 10 courses in the specialization. So number one, as usual, kind of a toolbox introduction-like thing. You'll get an introduction to the main tools and ideas. It gives you an overview of the data, questions, and tools that data analysts and scientists work with. There's two components. First is conceptual, so actionable knowledge, turning data into actionable knowledge. And the second is practical, so getting used to tools like version control in GitHub, Markdown, Git, R and RStudio. It's really a course in R, and then Markdown is kind of a way to publish that in RStudio. So R programming. In this course, you will learn how to program in R and use R for effective data analysis. So you'll learn how to install and configure software necessary for a statistical programming environment. It's really not difficult at all. They're making it sound like something crazy. You pretty much install R, and then you can install RStudio. And getting the libraries is actually very, very easy. And so as it says, accessing R packages, writing R functions, it's very easy stuff. Getting and cleaning data. So before you can work with data, you have to get some. This course will cover the basic ways that data can be obtained. The course will cover obtaining data from the web, from APIs, from databases, and from colleagues in various formats. It will cover the basics of data cleaning and how to make data tidy. So tidy is kind of a library in R as well. That's why they're using the tidy thing. Tidy data dramatically speed downstream data analysis. I don't think that's a proper sentence. Maybe I'm confused. The point is cleaning data. That's what they're trying to say here. Exploratory data analysis. So as you can see here, the ratings, they're starting to decrease a lot. All courses generally do this. This one drops off a lot. 33,000 ratings, 22,000 ratings, 8,000 ratings, 6,000 ratings. It's going down for sure. This course covers the essential exploratory techniques for summarizing data. As well at the bottom, it says statistical techniques to visualize high dimensional data. Many courses will not talk about that, and so I'm very happy that they cover that. Very important skill to properly visualize high dimensional data, because most of it actually is. Reproducible research. So basically the idea here is making sure that you can have something, well, it said the word reproducible. I don't know why you need a whole course on that. I feel like that's a little bit excessive, but it is important as a concept in that you need this, because there's a lot of different things that are like research papers that are like baked as in, hypothesis testing. The point of it is to do a test right the first time, check your p-value, and see if something's interesting. But what you can also do is do something 100 times, and if as long as it's interesting once with just one of the samples, then your report is, I guess, interesting. I call it baked, and many people call it baked. And so what they're doing here is saying, making sure that your research is reproducible. It has to be reproducible, because then someone else that doesn't know what you're doing, that doesn't trust you, they shouldn't trust you, can go and do what you did, understand what you did, get the same result, and believe you, basically. Okay, statistical inference. So getting into more complicated statistics. Statistical modeling, data-oriented strategies, and use of designs and randomization in analysis. Yes, it's important to understand randomization techniques. It's actually not as simple as just making things random. Furthermore, there are broad theories: frequentist, Bayesian, likelihood. Actually, frequentist and likelihood, I believe, are the same thing. Bayesian goes into the different category there. I'm going to stop reading that there. Basically, the point here is that statistical inference, it's complicated statistics. It's using data to make arguments about something, to understand generally a population. So I believe that the mean of this population is this, that it follows a normal distribution. You can use either of these types of methods to do that. So it's a very important course. Basically, is a long-winded way of trying to say this is very, very useful. Trust me. Regression models. Okay, this does absolutely deserve a course. This deserves 10 courses or a whole university course or two. But what they'll cover in here is something very important. So regression models are a subset of linear models, and they are the most important statistical analysis tool in a data scientist toolkit. Why are they the most important tool? Not because they're the most accurate. Linear models are generally inaccurate, but understanding how they work, as well as ANOVA, is really, really, really important, because all the more complex stuff, you need to understand this first. And for interpretation, to make a model that's interpretable and to understand how the inputs relate to the outputs, that is what linear models are for. So very, very important topic here. Practical machine learning. So as I just said, linear models are not always accurate. Stuff like these methods: classification trees, naive Bayes, random forests, as well as neural networks, although I don't believe they ever get there. That's okay. Nonlinear models like this are very, very important. Any of these types of models may be the best one. We're not sure which is the best one. We also teach important topics such as training and test sets, overfitting and error rates. Really, really, really fundamental topics right here. If you are taking a specialization, make sure you hit that section and understand that really, really well. Okay, I'd say that's the most important piece here, as well as the linear regression stuff as well. Developing data products. Okay, so now basically from behind here, course 8 and earlier, we're kind of assuming that you are able to visualize and understand data, you're comfortable with your toolkit, you can make a machine learning model if you think that's appropriate. And now that you have those skills, what do? Data products. A data product is the production output from a statistical analysis. Okay, whether that's a machine learning model, whether that's a clustering, like some sort of unsupervised learning technique, which is just about understanding data. No matter what it is, you're trying to make some sort of a product. It doesn't necessarily have to be sold. It's just some sort of an output. So this course will focus on statistics fundamentals of creating a data product used to tell a story. So that's also another buzzword people have been using, like data storytelling. I'm not really huge on that term, although I am passionate about storytelling and obviously data. Making content like this, trying to output it and present it in an approachable way, an interesting way, Same sort of thing here. Like if you do statistical analysis, you need to tell the story, make sure people understand it, engage in it, and actually want to read what you're saying or listen to what you're saying. So that's a good thing to do. Data science capstone, the project. Of course, there's a final project drawn from real-world problems. Not going to get into that, but that is a very common thing to do. Some sort of project capstone, great. Okay, so what are my thoughts on this? Great, actually. I'm not going to do some sort of a rating. I think it's great. It is in R, which, if you ask me, I'd probably recommend Python over R, and so I'd still probably recommend the IBM Data Science over this. But if you like R, or you're trying to test them both out, you're trying to see which language you like more, give this a shot, and I think you'll really enjoy it. So there it is. I hope you liked it. If you're not subscribed to the channel, please subscribe now. JK. Just look at the channel, take a look at the videos, and see if it's something you're interested in, and choose to subscribe on your own terms. And yeah, do drop a like on the video if this one gave you value, and I'll see you next time. Thanks so much.